Hello students, last class we have seen circular linked list. This class will see doubly linked list. Each node of a doubly linked list has three parts. In case of circular linked list and single linked list, only two parts, info and next. But in case of doubly linked list, there are three parts. First one is info, second next and previous. These are the three parts. The info part contains the data element, while the next and previous parts contains the address of the next and previous node respectively. So next part will contain the address of the next node, previous part will contain the address of the previous node. The next part of the last node of the list contains a null. So next part of the last node will contains the null value, indicating the end of the list. The beginning of the list indicated with the help of a special pointer called first. The main advantage of a doubly linked list is what it allows for both forward and backward traversal. So in case of doubly linked list, we can traversal from forward direction or backward direction. This is the logical representation of doubly linked list. Here, this is the first one node, two node, three node. Here, previous one. This is the previous node, info part and next part. Pointer to the previous node. It is pointing to the previous node. Info part contains the data element. Next part contains the pointer to the next node. It contains the address of the next node. This is the first pointer. First is a pointer. It points to the first node. Last is a pointer. It points to the last node. The implementation of a doubly linked list involves two tasks. One is declaring the list node and defining the list operations. So, what is the declaration of doubly linked list? The following structure declaration defines the node of a doubly linked list. Struct node. Struct is a keyword. Struct is a keyword. Node is the structure name. Int info. Int is a data type. Info is a value or member. Struct node star next. It's a pointer. Struct node star previous. There are two pointers, next and previous. Close bracket. Type definition struct node. So is the user defined data type. Node is also a data type like int character double. So this is the user defined data type. The above structure declaration defines a new data type called node that represents the doubly linked list. The node structure contains three members. One is info for storing integer data values, next for storing address of the next node, previous for storing the address of the previous node. Doubly linked list operations. So usually there are four operations performed on a doubly linked list. One is insert, delete, search, print. The insert operation in doubly linked list is performed in the same manner as a singly linked list. The only exception is the additional node pointer previous is used here. So here previous is additional pointer we use to be updated for the new node at the time of insertion. Write an algorithm to insert an element at the end of the doubly linked list. So this is the algorithm for inserting an element at the end of the doubly linked list. Insert value. Step 1 start. Step 2 set PTR. Set the PTR value equal to address of new node. So it allocates the new node and assign its address to the new node. So PTR is a new node is assigning the address of the new node to the PTR. Step 3 set PTR of info equal to value. So it's setting the value of info. PTR of info will be setting the value of value. Store the element value to be inserted in the info part of the node. So here this info part of the linked list contains the value. So it is storing the value to the info part. Step 4 if first equal to null means check whether the existing list is empty. It is checking whether the list is empty or it contains some elements. So if the first is equal to null means if it is true, then go to step 5. If first equal to null, here what will happen? No elements are there in a list. Then set first equal to ptr. Now a new address, the new node will be setting into the first node, and last is equal to ptr. So that is also last. Update the first and last pointers. Step 6, set ptr of next equal to ptr. ptr of previous equal to null. Here ptr of next and ptr of previous. So the new node next value and new node previous value will be assigned to null value. Okay, because there is no elements in the list, only one node is there. And go to step 8. Stop. If first equal to not equal to null means some elements are there in the list means, then go to step 7. In step 7, set last of next equal to ptr. So last value of next will be adding to the, at the end we are adding one element, one node means, so last of next will be having the address of ptr. So ptr will be assigning to this node. Then ptr of previous will be having the last. The last address will be having the ptr of previous. ptr of next equal to null and last is equal to ptr, updating the last node. Link the newly created node at the end of the list. Step 8, stop. Next, delete operation. The delete operation in a doubly linked list is performed in the same manner as a singly linked list. The only exception is that the additional node pointer previous of the adjacent node is also required to be updated at the time of deletion. So in the while inserting also we have to update the previous node. Here also we have to update the previous pointer previous of the adjacent node in the delete operation. Write an algorithm to delete an element from a doubly linked list. Delete value. Value is deleting here. Step 1, start. Step 2, set location equal to search. Here it called the search module to search the location of the node to be deleted. Which node we have to delete that. For that node we have to search. Search that node. So we have to allocating the location and assign it to the location pointer. Location is a pointer, assigning the search value. If location is equal to null, go to step 4, else go to step 5. If location is equal to null means here there are no elements or nodes in a list, then delete operation unsuccessful, element not found. Otherwise, if location is not equal to null, then step 5. In step 5, if location is equal to first, go to step 6. Location is equal to first means the element which we are going to delete will be presenting at the first node. So then go to step 6. If first equal to last, go to step 7. First equal to last means only one element is present in the list. Step 7. In step 7, set first equal to last equal to null. Okay, only one element is there, that is setting the first and last element will be null, and go to step 9. Step 9, return delete operation successful and stop. So we found the element which we want to delete, so that element is deleted and stop. Now if first is not equal to last, then go to step 8. In step 8, first of next equal to previous, first of next and previous is equal to null. So we are setting the first of next and first of previous will be null, and first is equal to first of next. Step 8, here location is equal to, if location is not equal to first, then go to step 10. Here step 10, set temp equal to location minus 1. Here it is assigning the location of the node present before the location to temporary pointer temp. So location, it is assigning the location of the node present before the location to the temp value. So temp is a variable. Step 11, if location is equal to last, go to step 12. See, if the location is, if the element which they are going to delete, that location is last, then go to step 12. Set last equal to temp, setting the temp value to last, and temp of next equal to null. So it's assigning the temp of next is equal to null, and go to step 15. Step 15 is return delete operation successful. Last element is deleted. If location is not equal to last, then go to step 13. What is there in step 13? Set temp of next equal to location of next. So location of next will be storing into temp of next. Then set location of next of previous is equal to temp. So location of next and previous both will be assigning the temp value. Then delete the location node. Here it's deleting the location node and set the adjacent next and previous. Next and previous will be assigning next previous pointers are assigning the previous node. So it's setting the adjacent next and previous nodes. So return delete operation successful, stop.